This video shows how quaternionic delta encoding updates a state tensor using quaternionic matrix multiplication. This technique is essential in 3D rotation tracking, robotics, and efficient state representation in physics simulations. You'll learn to build the quaternionic matrix, interpret the delta update rule, and connect it to hyperbolic projections. We'll first see how a quaternion W plus xi plus yj plus zk becomes a 4x4 matrix. Then we apply the delta encoding rule, where the new state equals delta q times the old state. Let's work through it on the diagram. How do you track a rotating system without storing every coordinate? Quaternionic delta encoding stores only the change between states, and that change lives in a beautiful 4x4 matrix. Students often think quaternions are just 4 numbers, but the real power comes from their matrix form, which lets us multiply states like ordinary linear algebra. Goals: build the quaternion matrix Q, then apply the delta encoding update rule. Step 1. A quaternion has 4 components, a real part W and 3 imaginary parts X, Y, and Z. Start with the quaternion W plus XI plus YJ plus ZK. Every quaternion corresponds to a 4x4 real matrix. The diagonal entries are all W. The off-diagonal entries are the imaginary parts X, Y, and Z, with carefully chosen signs that encode quaternion multiplication. Now we have a matrix. Let's see how it drives the state update. Step 2. Instead of storing absolute coordinates, we store only the change delta q between states. Delta q captures the change from the old state to the new one. The new state equals delta q times the old state. We store only the increment delta q, not the full coordinates. This is delta encoding, and that is the quaternionic delta encoding update rule. Whenever you track an evolving rotational system, store the increment between states rather than the absolute coordinates. Lift the quaternion into its 4x4 matrix form, then left multiply the old state by delta q to get the new state. This update rule is compact, exact, and avoids the drift you get from storing absolute coordinates.